Hello, and welcome to the Michigan Tech Aerospace Enterprise Design Expo presentation for the spring semester of 2021. Today, I'm going to introduce you to the Aerospace Enterprise, as well as the projects that we're currently working on. The Aerospace Enterprise is an undergraduate student team that builds satellites for class credit and for senior design. The program is organized into several subteams, comprised of a wide variety of engineering and humanities majors. One of the main goals of our program is to be able to provide any person of any major with an opportunity to work on spacecraft and space systems, regardless of their prior experience with aerospace engineering. Our enterprise was started a little under 2 decades ago because of a large request from the student body to have an enterprise dedicated to aerospace engineering. Being one of the oldest enterprises on campus, and the current largest enterprise, we have become the primary pipeline to full-time opportunities in the aerospace industry for Michigan Tech students. Our program continues to work on 2 missions named Auris and Stratus. Those 2 missions will be explained in more depth in the coming slides. Our enterprise has 2 core goals that it aims to achieve. The first is to educate the future leaders of the aerospace industry by providing undergraduate students hands-on space systems engineering project experience through the design, test, and integration of spacecraft. The second goal is to advance U.S. space technology by solving real-world challenging problems. The satellites we build aren't just student science projects. These are real satellites with real missions that are directly relevant to current U.S. military and NASA needs. One of the other goals of our enterprise is to provide continuous education opportunities to our members. An example of this are the optional weekly Saturday morning workshops that we hold, which we call Straturdays. These are work meetings designed to allow members to see what each subgroup in the team is working on, as well as to provide an opportunity for members to learn about concepts that they may not be directly working on. Our team structure can be seen in the figure in the bottom right-hand corner. Our faculty advisor is Dr. Brad King of the Mechanical Engineering Department, who also serves as the principal investigator for each of our missions. Student leadership starts with a program manager and the chief engineer, who report directly to the advisor. They each oversee a team of engineers, who together comprise the leadership team of each of the group's subteams. The vast majority of the enterprise is made up of members, who are assigned project work in one of the group's subteams. Our enterprise primarily operates out of 2 spaces within the Mechanical Engineering Mechanics building. The first is our Aero Lab, which is in the basement of the building. This is a general workspace for our team, where prototyping and simulation occurs. The second is the Clean Room, a Class 100,000 sterile environment where the testing and integration of our flight units occurs. This is where our primary test stand is located, which can be seen through the large window separating it from the first floor of the Mechanical Engineering building. The first of our current missions is Auris. Latin for ear, Auris is a pathfinder mission whose goal is to demonstrate a low-cost platform capable of exploring the interference potential of geostationary satellites. Auris will generate maps of the beam patterns radiated by a geostationary satellite by measuring the radiated power and locate the satellite via multilateration. In other words, the purpose of the Auris mission is to provide a way to monitor what other satellites are doing in space. This will be done by building a spacecraft that can simultaneously monitor where other spacecraft are and how strongly they're communicating with the ground. The data generated from this mission can be used to help both commercial and governmental entities. Here is a brief overview of the first objective. Data is collected while passing underneath the target satellite and is processed on board, and then sent to the ground. This data is then used to build spatial maps of what the target satellite is transmitting, such as the figure in the bottom right. The second objective of the mission is similar. Our spacecraft, along with 3 ground receivers, will listen simultaneously to a target satellite. Using information from those collections, a constrained optimizer is used to determine the physical location of the spacecraft when it transmitted that message. The second of our current missions is Stratus. The purpose of this mission is to demonstrate an inexpensive and upwardly scalable architecture capable of imaging clouds in the infrared spectrum and generating usable data for validating and improving existing climate and weather models. In other words, the purpose of Stratus is to show that it's possible to build a small spacecraft capable of doing some of the things larger spacecraft can do. In this instance, the mission is focused on thermally imaging clouds, which can help build and refine weather and climate models. Here you can see a graphic describing the first objective of the mission, obtaining images that can be used to measure cloud fraction, which is a method of calculating the cloud coverage over a particular area on Earth. As you can see, the spacecraft will be pointed towards the Earth while in orbit, so that it can obtain pictures that can be used for this process. The second objective of the mission is focused on different properties of clouds, their altitude and speed. To satisfy this objective, the satellite will spin while pointing downwards so that it can capture multiple images of the same cloud. This allows us to build a 3D model of that cloud and determine how high it is and how fast it's moving. Once again, this mission addresses 4 main areas: the scalability of this type of spacecraft, its relatively low cost, potential research benefits, and the education of our students. Moving forward with the enterprise as a whole, we are always looking to provide our members with fun and relevant opportunities in the industry, such as attending conferences like the SmallSat conference in Logan, Utah. We strive to continue to be Michigan Tech's pipeline to the aerospace industry, preparing students for the challenges and rigor of building spacecraft. That's all I have for you today, and I thank you for your attention. Below are our social media accounts, which we encourage you to follow. If you have any questions, feel free to reach out to aerospace@mtu.edu. Thank you very much.